So welcome to this latest video on 162 Maths, and in this video we'll be going over some past GCSE Maths questions related to upper and lower bounds. Now as always, I'll include a copy of the questions that we go through in this video as a link in the description. I'll also include a link to a lesson that goes over this topic in greater detail. Now before we get started, let's just have a quick overview over what it is you need to revise when studying this particular topic. Now in terms of what you need to know how to round numbers to place values. So when you're asked to round numbers up to the nearest 10, 100, 1000, or maybe to the nearest 50, 5, or even 10th, 100th, 1000th, etc. You also need to know how to round up to decimal places and significant figures, and also know where positions are in those particular numbers. When you know what, let's say, to two decimal places, what that means and what the third significant number represents as well. You also need to know when values are integers or decimals. In other words, when data is discrete or continuous. So for example, if you're dealing with people, that can't be decimals, it has to be to the nearest integer. Same thing with money, you can only round money up to the nearest penny, etc. Whereas things like height, weight can be continuous, you can go right up to the upper limit. You also need to know and understand how to find the upper and lower bound of calculations, which is basically what we're going to move on to now. Now in terms of the calculations, this is something that you really do need to know, and if it's worth revising like a spelling test, then it's really important that you add this to your revision notes when revising this particular topic. Now when you are adding two numbers together, to get the lower bound you want the smallest a and the smallest b. If you want the upper bound to the calculation of a plus b, then you want the biggest a and the biggest b. However, when you are taking away, you want the smallest a and the biggest b for the lower bound, and for the upper bound you want the biggest a and the smallest b to get the highest possible value. When you're multiplying it, that's the same as adding. So to get the lower bound you want the smallest a and the smallest b. For the upper bound you want the biggest a and the biggest b. And when you've got a fraction, you want to get the lower bound, you want the smallest numerator and the biggest denominator. But if you want the highest value that fraction can be, then you want the biggest numerator and the smallest denominator. Now before we get started working through these exam questions, a little reminder that you can access these questions by clicking on the link in the description below, and I'll also include a lesson link which goes over this topic in greater detail. Now these questions do carry quite a lot of marks, so it's really important that you do show full working out, and that includes writing down both the lower and the upper bound of each of the numbers in question, even though you may only use one of them. So looking at question 1, it says that school A has 1200 pupils to the nearest 100 and school B has 1750 pupils to the nearest 50. Work out the maximum possible total of the pupils. So for this, if we look at school A, now the upper and lower bound to the roundest to the nearest 100 is going to be 1150 to 1250. And the reason how I've got that is 1200 plus or minus half 100, which is 50, and that will give me my upper and lower bound. Then doing the same to school B. This has been rounded to the nearest 50, so that's going to be 1750 plus minus half of 50, which is 25. So that's going to be an upper and lower bound of 1725 to 1775. Now in terms of the actual limits, 1250 is not actually correct because obviously you can't have decimal people, so that's going to be 1249, and likewise for the school B the upper bound is going to be 1774. Now to get the maximum possible total of the pupils, I'm guessing we're adding those numbers up, so we go for the upper bound of both, which is these two numbers here. So here the max sum is going to be 1249 plus 1774, and that gives me an answer of 3029. Then moving on to question 2, it says Alf needs cement. Cement is sold in bags that have a mass of 25 kilograms to the nearest kilogram. His trailer has a safe working load of 220 kilograms to the nearest 10. Work out the greatest number of bags that the cement can be sure to carry safely on the trailer. So looking at this, if we look at the cement, and again we work out the upper and lower bound, so that's going to be 25 plus or minus 0.5, so that's going to be 24.5 to 25.5. and then the trailer is going to be 220 plus or minus half of 10, which is 5. So that's going to be 215, and let's just call that N. It doesn't really matter what letter we call it, and 225. So then from this, to get the number of bags, it's going to be the weight of the trailer divided by the weight of a bag. Now, because we want the greatest number, we need the greatest fraction. So that's going to be where, or the greatest number that we can safely carry. So that's going to be the lowest. So here then we want the lowest, which is the worst case scenario. So here we want this to be the smallest and this to be the biggest. So that's going to be 215 divided by 25.5, and if I type that into my calculator, I get an answer of 8.43. So the safest number of bags that I can have is going to be 8. Moving on to question 3, it says Atia's car can safely carry a maximum load of 320 kilograms. She wants to use her car to carry 5 bags of sand, each with a mass of 12.5 kilograms to one decimal place, and 10 bags of cement, each of a mass of 25 kilograms to the nearest kilogram. Can she definitely use her car safely to carry the bags of sand and cement? So first of all, let's have a look at the sand, and again work out the upper lower bound. So here we've got 12.5 to nearest one decimal place, so that's going to be 12.5 plus or minus 0.05, because half of a decimal place is 0.1 divided by 2, which is 0.05. So that's going to be 12.45 to 12.55, and then the cement is going to be 25 plus or minus 0.5, so that's going to be 24.5 to 25.5. Now we then need to work out the quantity. So 5 bags of sand, so if I times this by 5. Now worst case scenario, what I want is the heaviest of each bag. So here we're going to do 5 times 12.55, which gives me an answer of 62.75. Then we're going to do 10 bags of cement, and we want the heaviest one, so 25.5, and that gives me an answer of 255. And then we just need to add those two numbers up, and if we add those numbers up, we get 317.75, and the car can carry a maximum load of 320 kilograms. So as you can see there, the answer is going to be yes. Then moving on to question 4, it says the length of a ball of string is 25 meters, correct to the nearest half meter. A piece of length of 7.4 meters, correct to the nearest 10 centimeters, is cut from the roll. Work out the maximum possible length of the string left on the roll. So looking at this, if we look at the ball of string, we've got 25 to the nearest half meter. Now half of half a meter is 0.25, so it's going to be 25 plus or minus 0.25. So the smallest value is going to be 24.75, and the biggest value is going to be 25.25. Then if we look at the length, now the length is 7.4 to the nearest 10 centimeters, so it's going to be 7.4 plus or minus 0.05. So then the length, upper lower bound, is going to be 7.95, 3.35 and 7.45. Now if we want the maximum length left, we're going to be taking away the 2. So I'm going to be doing A and B. So I'm going to be doing A minus B, and I want the biggest possible answer. So I want the biggest A, which is 25.25, and I want the smallest B, which is 7.35. And if I take away those two numbers, then I end up with an answer of 17.9. And that's in meters. Then moving on to question 5, it says that a formula connecting pressure P, force applied F, and contact area A is P equals F over A. F is 242 sig fig, A is 9.62 sig fig. Work out the upper and lower bound of P. Give your answers to 3 sig fig. So looking at this, rounding to 2 sig fig for F, that's to nearest 10. So that's going to be half of 10 is 5, so that's going to be 240 plus or minus 5. So F is going to be 235 to 245. And then looking at A, well here our second sig fig is a tenth, so it's going to be 9.6 plus or minus half of a tenth, which is 0.05. So A is going to be 9.55 to 9.65. So then if we want our lower bound, we want the smallest F, so that's going to be 235 over the biggest A, which is 9.65, and that gives me an answer of 24.5352 blah blah blah. Then if I want the upper bound, I want the biggest F, which is 245, and I want the smallest A, which is 9.55, and that gives me an answer of 25.6544. So then all I then need to do is round those two numbers up to 3 sig fig, so I get upper bound of 25.7 and the lower bound of 24.4. Then moving on to question 6, it says here we've got a calculation, and again we want to work out the lower bound of T. So for this I want for the lower bound of T, I need the smallest at the top, and 4 can't change, so I want to make 3m minus w the smallest. Now to get the smallest when I'm taking away, I need this to be small and this w to be big. So then working out the upper and lower bound of m and w to 1 decimal place, that's going to be 9.2 plus or minus 0.05, which gives me 9.15 to 9.25. Then the same with w to 1 decimal place, that's 24.3 plus or minus 0.05, that's going to give me 24.25 to 24.35. So then picking out this calculation for me to give you the smallest value, it's going to be 3 lots of the smallest m, which is 9.14, minus the biggest w, which is 24.35. Then if I work that out and then divide that all by 4, that's going to give me the smallest value of T, which if I type into my calculator gives me 31 over 40 or 0.775. Then moving on to question 7, it says the dimensions of a circular stepping stone are to the nearest 0.1 meters. A force of 230 newtons is applied to the stepping stone. The force is to the nearest 5 newtons, and we've got the pressure formula given, and it says work out the upper bound of the pressure, give your answer to 4 sig fig, and you must show your full working out. So looking at this, let's just first of all look at the force, and the force has been rounded to the nearest 5 units. So F is going to be 230 plus or minus 2.5. So the upper bound then is going to be 227.5 to 232.5. So then that's the upper low bound of the force. Then to work out the length, well the length has been to the nearest 0.1, so R is going to be 0.2 plus or minus 0.05. So r is going to be 0.15 to 0.25. Now from this I can then work out the upper bound of the area. So the lower bound of the area is going to be pi times the smallest r, which is 0.15 squared, and the upper bound is going to be pi times the biggest r value, which is 0.25 squared. Now entering them both on the calculator, the lower bound is 9/400 pi and the upper bound is 1/16 pi. Now I'm just going to leave that in terms of pi. Then to work out the upper bound of pressure, it's a fraction, so I want the biggest F and I want a small a. So the biggest force is 232.5 and the smallest area is 9/400 pi. So if I type that all into my calculator, I get an answer of 3289.202. But I then need to round this number up to 4 sig figs, so in other words to the nearest unit, which gives me an answer of 3289. Now on the mark scheme it will accept if you had 3288. So again, just a word of notice, but I get 3289 because I've used the exact values. Moving on to question 8, it says the area of a triangle is 150 centimeters squared to the nearest 10 centimeters square. The length is 16 centimeters given to the nearest centimeter. Work out the maximum possible value of the height h. So looking at this, if we look at the area, now the area is to the nearest 10 square centimeters, so that's going to be 150 plus or minus 5. So the lower bound is going to be 145 to 155. Now to work out the area of a triangle, it's A equals B times H divided by 2. So if I do 2A equals BH, now for this I want the biggest value of H. So for this, if I look at the length, so in terms of B, well that's going to be 16 plus or minus 0.5, so that's going to be 15.5 to 16.5. So in order for me to have the biggest h, I need to use the smallest base. So from this I've got 2 times 155 equals the smallest value, which is 15.5 times h. Then working this out, I get 310 equals 15.5 times h. So h equals 310 divided by 15.5, and that gives me an answer of 20. Then moving on to question 9, which is our last question, it says b equals c over the root of d. C is 160.5 to 1 decimal place and D is 625 to 3 significant figures. Work out the upper and lower bound of B. Give your answers to 4 significant figures. So looking at C, I can see C straight away is going to be 160.5 plus or minus 0.05. So the upper lower bound for C is going to be 160.45 to 160.55. And if I do the same with D, D is going to be 625 plus or minus, now the third significant figure is a unit, so it's going to be 0.5, so that's going to be 624.5 to 625.5, and there are my upper and lower bounds for each of those two. So then to get the lower bound of this fraction, I need the smallest c, which is 160.45, divided by the biggest d value, which is going to be the square root of 625.5, and that gives me an answer of 6.415. Now the upper bound is going to be the biggest c value, which is 160.55, divided by the smallest d value, which is the square root of 624.5, And if I word that out on my calculator, I get an answer of 6.425. So each of those numbers have been written to 4 significant figures. So it's going to be 6.425 and 6.415. Then finally, for 9b, it says comparing your answer from A, state the value of B to a suitable degree of accuracy. So in other words, what we're looking for is the midpoint between 6.425 and 6.415, which gives me an answer of 6.42. And there we go.